Now here we have a set of x's here. Now we're gonna have a point. I'm just gonna plug a point there. Suppose this point, I'm just gonna coordinate it. Let's just say 6 is to some about 4. Let me have a coordinate of A being 6 is to 4. Now this point, we can move it everywhere along this Cartesian plane. We can move it everywhere along this Cartesian plane. We can move it up or move it down or move it to the left or to the right. We can basically manipulate this. Now if we shift this 2 units up, it's only going to affect the y value because we're only moving up, and this set of this axis, this y axis, the vertical axis, is for up and down. So if you're shifting something up or shifting it down, you only affect it vertically like this. So it has nothing to do with the x-axis. That means the 6 will still remain the same. And if we move it up, we're gonna have a new coordinate of what? 6 is to 6. You'll just add 2 to that if you're moving it up, and if you're shifting it down, you're gonna subtract 2 from that. Okay, let's proceed. Now if I want to move it left or right like that, I'm just gonna subtract 2 from that if I move it to the left. So it's gonna be minus 2 from the x, and if I move it to the right, then I'll add 2 to the right. Stay with me there. Okay, now if I want to move this point, across the x-axis, if I want to reflect this about the x-axis, remember this is 6 is to 4, meaning that the vertical distance here, it's 4 units. The vertical distance here, it's 4 units. Remember, it's 6 is to 4, so the vertical distance is 4 units from the x-axis. Now if I want to reflect that about the x-axis, now notice that it must remain at the same distance from that. The x-axis should be the mid distance between this point and its reflection. That means that I'll have another 4 units on the side. So I'll have 4 units on the side, meaning that the new set of coordinates will be what? 6 is to minus 4. If I reflect that about the x-axis, notice that if I reflect this about the x-axis, it only affects the y coordinates. It only affect the y coordinates. Notice that the y went from positive to negative. So you see something here, see the pattern here. But now if I have this coordinates and I reflect it about the y-axis, now notice this. Now the distance from this point, this new point, now we have a new point here now, and the y-axis here, the new point and the y-axis is gonna be 6 units, because we're not changing it vertically, we're only moving it horizontally like this, because we want to reflect that about the y-axis. Now it must remain the same distance. It must remain like the same distance from the y-axis. So that means we'll have another 6 units here. We'll have another 6 units. That means the new set of coordinates from this point will be minus 6 is to minus 4. Notice that only x was affected. You see that only x was affected when we reflect about the y-axis. You see what I did there? Now let's say I have a function passing through the point A. Suppose I have a function passing through the point A, and I want to reflect that function such that those reflections correspond with this. Suppose that I have y equals f of x. Suppose that you have a graph defined by this. Y equals f of x. Now, if I want to reflect this about the x-axis, let's start with the x-axis for a second then. Notice that the first time I did this, I said it's 4, and I said that this is 4 units since the y value here is 4. And I said that this should be the same distance from the x-axis. So because that we are reflecting it about the x-axis, that means that we'll have a midpoint between the new point, the reflection point, and the midpoint of that. Then you can basically work that out. Now, notice that y went from positive to negative. It went from positive to negative. That means that if I want to reflect, this means that f at x, if I put the negative sign here, minus f at x, this is the reflection. This is the reflection of f of x about the x-axis. About the x-axis. Minus f of x is a reflection, because basically I'm saying that f of x is some function that passes through this point. It's some function that passes through this point. It can be a straight line, a parabola, or a cubic function, or any polynomial or rational function, or an algebraic function. As long as it passes through this point, then it can stand this reflection. Now, this will be the reflection of f of x about the x-axis. So this is what I was basically showing. And now you see that here, if I reflect about the y-axis here, if I reflect this point about the y-axis, this means that the y-axis is the midpoint of the new point and the original point. Notice that x is affected. X goes from positive to negative. That means that f into minus x, this is the reflection of f of x about the y-axis, So this is basically the stuff that I was introducing, but we can like manipulate this point further. It's not only about reflection and shifting it up and down. Okay, let me focus on this, shifting the function up and down. Now, if I add a constant to a function, notice that the constant is outside this. Then if I add a constant and suppose that that constant is greater than 0, then we shift f c units up. We shift f c units up. And if I have f of x minus c, where c greater than 0, then we shift f c units down. So this is basically what I was saying here. If I want to move this up, then I'll basically add 2, and if I want to move this 2 units down, then I'll basically subtract 2 from that. So this is just the mathematical way of representing that. It's the formulae of like the general formulae of like shifting that. Where c is any number, we can like shift this anyhow, any units you want. But now notice that if I want to like shift this to the left, then I will have something like this. Yeah, I know it's positive, right? It's different from this one. You'll have to add, because if you solve for x plus c equals to 0, you'll get x equals minus c. You'll get a negative solution of that. That means we're moving to the left. So if I have this, then this means where c is greater than 0, this is important, c greater than 0, then we'll have this as shift f c units to the left, and then if I have f into x minus c, where c is greater than 0, then this will be the same as you shift f c units to the right. These are not all the transformation we can make on a function. Notice that I'm gonna make an example with the same point. I can reduce by a factor. I can reduce the distance between this point and some reference point. We'll have another point. Suppose we have this point there. You can like reduce this distance by some factor. This distance, you can reduce it by a factor. You can like half the distance. You can put a here You can halve the distance, and if you have the distance, that means that x, the new x value will be 3. You get that? You can reduce the distance, you can shrink that distance, you can basically shrink that distance. And the same is true for vertically. You can stretch it vertically, or you can like stretch it horizontally or shrink it. You can also shrink the distance, you can also shrink this distance by some factor. So we'll have to talk about horizontal transformations and some vertical transformations. So suppose we want to shrink a function. If we want to shrink a function horizontally, now we want to shrink a function horizontally. Now, notice that this point is 6:4. If I want to shrink that, I want 4. I will still want to get the same y value here. And then that means that I'll have some point ax is to 4. Ax is to 4. But now I know that the new value is gonna be like, it's gonna be 3. The new x value must be 3 because I want to shrink that horizontally. So that means if I want to shrink that horizontally by a factor of 2, then a will have to be 2, because 2 times x, we still need to get this value 2. Remember, the new set of coordinates will be 3:4. Now if you multiply 2 by 3, you'll get 6. We need this to give us this value. So a is just some factor in there that allows us to shrink the distance there. So when you shrink a function horizontally, then you're gonna put some constant, some value inside that function. This I'm gonna say a is greater than 0. Or suppose, let me just be mathematically strict on this. Let's just say a is greater than 1. A is greater than 1. In any case I'm gonna do here, a should be greater than 1. Now for a greater than 1, and then this is a horizontal shrink. We shrink that function horizontally like I just showed here. Now if you want to shrink it vertically, it's just the opposite of this. You're just gonna put this outside, and then you're gonna put a reciprocal of that. So basically here what I'm saying is, if you want to shrink that vertically like this, we want to halve the, suppose we want to halve that distance, so we'll have some point 6:2. We'll have some point 6:2, because that's basically halfway, so we just shrink that distance by half. How do we do that? So we're gonna have 1 over a, where a is 2, is the shrinking factor. If you put 2 here, you're gonna get half. It makes sense, right? If you put 2 here, it's gonna be half, so we just shrink it by a factor of 2, then because that's gonna be half here, so you'll have 1 over a into f of x. So that's shrinking f of x vertically by a factor of a. That makes sense, right? Okay, then we can also stretch a function. So stretching a function horizontally and vertically is gonna be like different. So now let's start with horizontal stretch. Now I want to extend this distance by some factor. Initially it's 4. I want to like make it some about 8 or something. So it's just the reciprocal of this. It's just the reciprocal of that. So when you reciprocate that, you'll have something like this: 1 over a multiplied by x, or x over a. It's still fine, but I write it like this so you see the notation. It corresponds with this one. Now you reciprocate this, you're gonna get a, and then you'll have f of x. So this horizontal shrinking, horizontal stretch, yeah, horizontal shrinking and horizontal stretch, and vertical shrinking and vertical stretch. So this is the properties of a function that you basically need to apply on that. Then you can be able to like shift and transform functions like that. So you can basically memorize this, then you can be able to apply it. So you can like basically apply multiple of this on the same function. You can shrink and do that, and then you can shrink and shift at the same time.